NCM Learning Center. Good morning, friends. NCM Learning Center continuously giving the online training those who are preparing for GATE, IAS, ISRO, TNEB, RRB and other government examinations. By using our channel, you can get the materials, tips and other notification. Recently, the NCM Learning Center have a WhatsApp group. By using the WhatsApp group, you can clarify your doubts. Then, the NCM Learning Center created an Android app. By using the Android app, you can access all the materials for the government examinations. Okay, now we will discuss an open problem how to identify the filter. The given circuit is whether low pass filter or high pass filter or band pass or band reject filter. Okay, if you solve this problem in a procedure wise, it will take long time and it will confuse you. So now I will give one shortcut techniques to identify the whether given op-amp circuit is low pass or high pass or band pass or band reject. Okay, definitely the shortcut techniques will help you for the government examinations. Okay, so just listen this video fully. We will discuss. First, you should know about the types of filter and its properties. Then only you can solve this problem. Okay. So first, low pass filter. The low pass filter means low pass. It will allows the low frequency signals and it will attenuate or stop the high frequency signals. If the input is low frequency, the output will be approximately equal to Vin or any magnitude. But if the input is high frequency, definitely the output will be 0. So if when omega is equal to 0, omega means angular frequency. When angular frequency, input angular frequency is equal to 0, the output will be very close to Vin or it will get an magnitude. But when the input frequency is infinite, very very high, definitely the output will be 0. Okay, if the circuit have such type of output, definitely the circuit will be a low pass filter. Second, the high pass filter. High pass filter means it passes the high frequency signals and attenuate low frequency signals. So when the input is low frequency or very close to 0, definitely the output will be 0. When the input is high, when the input frequency is very close to infinite, the output will be very close to Vin or it have a magnitude. Okay, so when omega is equal to 0, output is equal to 0. When the input frequency omega is equal to infinity, V naught approximately equal to Vin or the magnitude, any one magnitude. Okay, this is the high pass filter properties. Then band pass filter. Band pass filter means it will allow a band of signals. If the frequency is less than this band, it stops. And if the frequency is higher than the band frequency, it stops signals. Okay, here this is the band. If the input signal is in between the band, it will allows. If the input frequency is less than this band or if the input frequency is higher than this band, it stops. So it means when omega is equal to 0, the output is equal to 0. When omega is equal to infinity, omega is V naught is equal to 0. This, if the circuit gives when the input is omega is equal to 0, V naught is equal to 0, and when omega is equal to infinity, V naught is equal to 0, definitely the circuit will be a band pass filter. Okay, next, band reject filter. Band reject filter is opposite to the band pass filter. So it rejects a band of signals. Okay, if the input is less than this band, it will allows. If the input is higher than this band, it will allows. Okay, so when omega is equal to 0, the output will be some magnitude. Similarly, when omega is equal to infinite, the output will be magnitude, some magnitude. Okay. Then notch filter. Notch filter means if the circuit allows only one signals, only one frequency signals, and stops all other signals, all other frequency signals, then the filter is called as notch filter. Okay. Now the procedures for how to identify the given circuit is low pass or high pass or band reject. Okay, these are procedures. The procedures, the first step, apply the input is omega is equal to 0, angular frequency 0, and find the value V naught. Okay, If the circuit have inductor and capacitor, inductor reactance, we know that inductor reactance XL is equal to omega into L. We know already know. Okay, when omega is equal to 0, the XL reactance value substitute here, we will get reactance is equal to 0. Reactance means resistance to the alternating current. If the resistance equal to 0, all the current flow from that path. Okay, just it act as short circuits. If the resistance equal to 0, it act as short circuits. Or inductor act as short. If the circuit have inductor, when omega is equal to 0, the inductor is act as short. So we may replace the inductor by short. Next, the capacitor, we know the capacitor reactance X is equal to 1 by omega into C. When omega is equal to 0, 1 by 0, 1 by 0 means infinite. Infinite means very, very, very high. Okay. If the reactance is very, very, very high, there is no current flow through the path. If resistance is very much high, there is no current flow here. So the capacitor act as open when omega is equal to 0. Okay. So we may replace the capacitor by open. So we may eliminate. Okay. If V0 is equal to 0, when omega is equal to 0, it should not be a low pass filter. Okay, it may be a high pass filter or band pass filter. If V0 have some magnitude, V0 is equal to Vin, when the omega is equal to 0, it may be a low pass or band reject filter. By using this step 1, we may eliminate any two types of filters. We can choose any two filters. Okay, so step 2, find V0 when omega is equal to infinite value. Now, inductor reactance XL is equal to omega into L, omega is equal to infinite. Substitute here, we will get XL is equal to infinite, reactance is equal to infinite. Reactance infinite means high resistance. High resistance means no current flow, so open. It acts as open. So inductor acts as open. Similarly, for capacitor, we know that X is equal to 1 by omega into C. When omega is equal to infinite, 1 by infinite is equal to 0. So there is no reactance, there is no resistance. All the current flows through this path, so it acts as short circuits. So capacitor is short. So we may replace the inductor and capacitor. Okay. In the first step, when omega is equal to 0, V0 is equal to 0. In the second step also, V0 is equal to 0 when omega is equal to infinite. If what will be the filter? The filter will be band pass filter. Okay, because when omega is equal to 0, the V0 is equal to 0. When omega is equal to infinite, also V0 is equal to 0. So filter will be a band pass filter. In the first step, V0 value is 0. But in the second step, when omega is equal to infinite some value, definitely it will be a high pass filter. Okay. In the first step, V0 is equal to V in some value. In the second step, V0 is equal to 0 if. So the filter will be a low pass filter. In the first step, V0 is equal to V in some magnitude. In the second step also some magnitude. Definitely it will be a band reject filter. So by using the step 1 and steps 2, we can select a filter circuit. We can choose a filter. Okay. This is the procedures. Okay. Now we will solve a problem. This is the problem. This is the GATE examinations problem. We have to identify the given circuit, whether the given circuit is low pass or high pass or band pass or notch filter. Okay. So use the procedures. Step 1, apply omega is equal to 0 and find V0 value. When omega is equal to 0, here capacitor reactance X is equal to 1 by omega into C. Capacitor reactance is infinite. Capacitor reactance infinite means it acts as open. Capacitor acts open. So we may eliminate the capacitors from the circuits. So now the circuit will becomes like that. Okay. So the capacitor is open, so we may eliminate. Now find the V0 from the circuits. The circuit is equal to the circuit when omega is equal to 0. Okay. So find V0. This is the inverting amplifier circuits. Already I discussed how to find the V0 for the amplifier circuits, op-amp circuits. That video link is given in the description of the video. Just use it. Okay. So the V0 for the circuit is minus V into R2 by R1, some amplitude. Okay, it's not equal to 0. It allows the low frequency signal. So it may be a low pass filter. Definitely it will not be a high pass filter. and bandpass filter and notch filters. Okay. So we may use another one step 2 also. When omega is equal to infinite, the capacitor X is equal to 1 by omega into C. When omega is equal to infinite, when 1 by infinite is equal to 0. So the capacitor act as short circuits. So we may replace the capacitor by short circuits. So now the circuit will become like this. The capacitor short circuits. Okay. Short circuit means resistance is 0 ohms. If 0 ohms parallel to R2, the total resistance will be 0 because R parallel formula 1 by R equivalent is equal to 1 by R1 plus 1 by R2. If you use it, the total resistance will be a 0. If total resistance is 0, we'll get V naught is equal to 0. Or otherwise, here V plus is equal to 0. By the upper concept, V plus is equal to V minus. Actual concept, V plus is equal to V minus. V minus is equal to 0. V minus is directly connected with V naught. So V naught is equal to 0. You may use any one concepts. Okay. When the frequency is high frequencies, it attenuates. So definitely the filter is low pass filter. Okay, these are the concepts. Now do it yourself. Try to solve this problem and command your answers. Okay. The first circuit, this question is asking gate instrumentation engineering 2009. You have to identify the given circuits whether low pass or high pass, band pass or all pass filters. Okay. The second question is asking gate EC department 2011 examinations. Third question is asked in Indian Engineering Service Examination 2019. Okay. Command your answers. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.